Hello Year 12, here's your 5 a day. And here are the answers. Okay, so today's lesson is further symmetry properties and the Pythagorean identity. So we're adding to the symmetry properties that we looked at in the last lesson, 6b. Now if we start with our unit circle again, we have a point here, p theta, which comes from a rotation of theta degrees, or theta radians, sorry, from the positive x-axis. I'm going to call the horizontal component A, the vertical component B. Hopefully you know that A is equal to cos theta, B equals sine theta. We're going to be using that. Now if I take that triangle and reposition it here, this angle here is theta, moving back from pi on 2. The height of the triangle is A, and the width of the triangle is B. Now, this angle here, well, that's pi on 2 minus theta. So I can call this point P pi on 2 minus theta. Let's think about what we can say about sine and cosine. So remember, sine, we talk about the vertical movement. The vertical movement for this is A. Now that's equal to this A here, which is cos theta. So sine pi on 2 minus theta is equal to cos theta. Similarly, this is the cos of that theta. Sorry, of pi on 2 minus theta. That's equal to sine theta. So cos pi on 2 minus theta is equal to sine theta. I can also take this triangle and move it past pi on 2. The A's and B's being the same. This angle now is pi on 2 plus theta. And for this point, sine of pi on 2 plus theta is equal to A. So that's equal to cos theta. Now, cosine of pi on 2 plus theta is negative B. Remember, we think of this as an xy axis. We've moved on the negative part of the x-axis B units. So it's negative B. That's equal to negative sine. So we can use these 4 results to work out other values. I'll give you a moment to read this example question. So sine of pi on 2 minus psi, that looks like this one here. So that's equal to cos psi. And we know from the question that that's equal to 0.8. Cos of pi on 2 plus theta, that's this one up here. That's equal to negative sine theta. I know that sine theta is 0.3, so negative sine theta is negative 0.3. Pause the video now while you have a go at question 1. Some of this will also draw on the work that you did in the last lesson, 6b. So, you should recall SOHCAHTOA from when you first started learning about trigonometry. In this triangle here, where I've got an angle theta and my hypotenuse is 1, this opposite side is 1 times sine theta, or sine theta. My adjacent side is cos theta. Now you should also remember Pythagoras Theorem, which states that a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the other 2 sides of a right-angled triangle. I can substitute the parts of this triangle in to get sine theta squared all squared plus cos theta all squared equals 1 squared. Now, I don't normally write this like this because it can get confusing, so I rewrite it as sine squared theta plus cos squared theta. This 3 lines here means is identical to 1. This will always be the case regardless of what theta is. Just a reminder, you know another identity, and that is that tan theta is identical to sine theta over cos theta. So let's have a look at how we can use that to answer some questions. Here we're given a value of sine x, and we're told that it's between pi on 2, that x is between pi on 2 and pi. So we need to find cos x. Now, this is my identity. I can substitute the value for sine x in. I can square that bracket and rearrange. This is 16 over 25, so I can square root. I know that cos is plus or minus 4 over 5. I need to know whether it is the positive one or the negative one. So I go back up to here, and I say to myself, so x is in the second quadrant. In the second quadrant, only sine is positive, so cos must be negative, and cos x must be negative 4 over 5. To find tan x, we remember that tan x is identical to sine x over cos x. I know what sine x and cos x are, so I can substitute them in, calculate, and simplify. Now, alternatively, you can think of a right-angled triangle. This is going to make more sense if I call this x in the context of the question that we've got here. So I know that sine theta, or sine x, is opposite over hypotenuse. Here I've got that sine x equals 3 over 5. So I can call my opposite side 3, my hypotenuse 5. It's going to be some ratio of those numbers to each other. It could be 6 and 10, could be 9 and 15, 3 and 5 is fine to use. Now, using Pythagoras, I can find the third side, which is 4. Then I can just read the values off. So cos x is adjacent over hypotenuse. Finally, I have to remember that I check what quadrant my angle is in. It's in my second quadrant, so it needs to be negative. Similarly, tan x equals opposite over adjacent. Check the quadrant to see that tan x is negative. So you can use this method as well. It's just really important that you don't forget to check whether it's going to be positive or negative. Have a go now at these questions using either method. For me, there's the wrong answer in the book for question D, but yours might have been changed. Thank you very much.